In this video, we're going to learn how to predict the products of chemical reactions. So that means you're going to be given the reactants and the arrow, and you have to figure out what comes after the arrow. Before we get started on that, I want to review something we've talked about before, which is the diatomic elements. So there's 7 elements on the periodic table that will always get the subscript 2, and that's because they do not exist in nature by themselves. They either have to be partnered up or they have to have a bond. So basically, anytime you see any of these 7 elements, they sometimes go by Brinkelhoff. So that stands for Br for bromine, iodine, nitrogen, chlorine, hydrogen, oxygen, and fluorine. Anytime you see any of those elements by themselves in a chemical reaction, like right here, that oxygen is by itself, it's going to have a subscript of 2. Another way to remember these is they do make the shape of the number 7 on the periodic table, except for hydrogen over here, and there's 7 of them. So let's start by looking at a synthesis reaction. So a synthesis reaction is when 2 elements come together to form a single compound. So in this example, we have magnesium plus oxygen. So we're going to write the formula that would form for the compound between magnesium oxygen. So that would be magnesium oxide. So we're going to combine the elements and write the correct formula, and then we're also going to balance the reaction. I do say correct formula because it's really easy to just assume that it's going to be MgO, but that might not always be the case, because remember, we're going to have to look at the charges and make sure they cancel out, and if they don't cancel out, we need to use the crisscross method. So let's take a look at it. We have magnesium. We look up magnesium's charge, and it's +2. We also have oxygen, has a charge of -2. So luckily the +2 and the -2 do cancel out. So that is just going to be MgO. So our right side of the arrow is going to be MgO. But we also have to balance this reaction. That's a very important step that we can't forget. So to balance this, I need to see that my oxygens are not balanced. I need to put a 2 right here to balance out my oxygen, and now to balance out my magnesium, I need to put a 2 right there as well. Just for another quick example, if we were going to do sodium plus sulfur, so the compound would be sodium sulfide. Sodium has a charge of +1, sulfur has a charge of -2. They don't cancel out, so that means I am going to have to crisscross. And my formula is going to be Na2S, not just NaS. And to balance that out, all I have to do is put a 2 right there. And then you're done. Decomposition, I'm going to go over 2 examples. This first one is what we call just a binary compound. It means it's just 2 elements. So when we have a decomposition and it's just 2 elements, they're just going to split up into their 2 parts. So if we have nitrogen and iodine, they're going to split up into nitrogen and iodine. Now this is where we have to remember those diatomic elements. Nitrogen and iodine are both part of Brinkelhoff. So that means they're going to be N2 and I2. So for this kind of decomposition, we're going to split up the elements and, of course, balance. So to balance this, I'm going to need a 2 right here and a 3 right here. And then you're done. Decomposition can get a little bit trickier if more than just 2 elements are involved. So in this one, we have KOH, which is potassium hydroxide. So it's still only going to split up into 2 pieces. And let me show you how you figure out what it's going to split up into. So you're going to need your reference packet. And in your reference packet on page 6, you have this whole list of all the reaction types and all the different reactions that can happen. So underneath decomposition, remember we said we have a potassium hydroxide. So if I look at this list, my eye catches on metallic hydroxides. Remember, potassium is a metal, so this is a metallic hydroxide. And next to that, we see that we have MOH, and M represents the metal. So this can be any metal can represent that M. So MOH breaks down into MO, so whatever metal bonded to oxygen, plus H2O. So that H2O, that's something that I can go ahead and fill in. But this MO is something I'm gonna have to figure out because that metal in our case is potassium. So I'm gonna have to write out the formula for potassium and oxygen. So potassium is a +1 charge, oxygen's a -2. Those do not cancel, so I'm gonna have to crisscross. So I end up with K2O. So my metal oxide is going to be K2O. And to balance that, I'm just gonna have to put a 2 right there. So the moral here is that if there's more than 2 elements in a decomposition, you need to look at the reference packet to figure out what's gonna come after. Here's one more example of a decomposition where we're gonna need our reference packet. So I have Na2CO3. I should recognize CO3 as a carbonate. So if I look at my reference packet, under decomposition, we do have metallic carbonates. So it looks like that metallic carbonate is going to split up into that metal with oxygen again, but this time with CO2, carbon dioxide. So I'm gonna have something plus CO2, and it's gonna be that metal oxide again. So this time we have sodium and oxygen. So that's going to be Na2O. And now all I have to do is balance, but actually, looks like we're already balanced, so that would be the final answer. The last one we're gonna look at in this video is combustion, and combustion is actually the easiest one. So you can even look in your reference packet for this. It says combustion is always going to be a hydrocarbon. That literally just means C something H something, okay? It's just some combination of carbon and hydrogen plus oxygen, so that'll be O2. Breaks down into carbon dioxide, which we should know is CO2, plus water, which is H2O. So every single time you have a combustion reaction, it's always going to break down into carbon dioxide and H2O. But we do still have to balance it. So let's look at how we're gonna balance this out. Remember, like we said before, always save oxygen for last. It will make your life easier. So right now, carbon's already balanced. Hydrogen, we have 4 over here and only 2 over here, so I'm gonna add a 2. And when I do that, I now have a total of 1, 2, 3, 4 oxygens. So I'm gonna put a 2 over here to balance my oxygen. And that's it.